Hello everybody. I thought it might be easier if I explain how to do each of the questions to the 2016 midterm in a video solution. That way you can hear the thought process and the reasoning rather than just see, oh, the answer is D and move on, or read someone else's explanation. I find I can often express more if I'm talking, and I can remind you of certain things that we learned in class or have talked about. I'm just going to be going through, there's only 32 questions, I'm just going to be going through 4 questions per video, and we'll start right off with 1 through 4. So if cos theta is 3 over 5, and theta is between 0 and pi by 2, tan theta is, okay, so this one's not so bad, we'll just use a little SOHCAHTOA. Remember with SOHCAHTOA, sine is opposite over adjacent, cosine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So if we put our little theta in here, 3 would be my adjacent, 5 would be my hypotenuse. Now for tan, I need the opposite over the adjacent. So I need to figure out this value here. Well, fortunately, Pythagoras' theorem comes to the rescue. 5 squared minus 3 squared is the other side squared. So that's 25 minus 9 is 16. 16 is 4 squared. So we put a little 4 here. And tan theta is opposite over adjacent, so we're looking at 4 over 3. And that's B. And then we move right along. It's question 2. Find all values of x in the interval 0 to 2 pi that satisfy 2 cos theta plus sine 2 theta, 2 cos x plus sine 2x equals 0. Alright, now I see this sine 2x. It immediately makes me think, oh, I know a formula for that. Okay, I notice I've got 2 2's, I've got 2 cosine x's. Let's factor those out. So either cosine of x is 0 or 1 plus sine x is 0. So when is cos x equal to 0? And we might think about our unit circle. Cosines are the y values, or sorry, not the y values, the x values. So whenever our angle is on the y-axis, and that happens up here at pi by 2, and down here at 3 pi by 2, which are both still in our range. So that'll work out. 1 plus sine x, when is that equal to 0? Well, when sine x is equal to minus 1, and that happens, sine is the y-coordinate. So when we're all the way down here, again, at 3 pi by 2. So pi by 2 and 3 pi by 2, where are those as answers? They're right here. They're A. Okay, and we're good to go. All right, what else? Okay, so 3. Sine x 2x plus cos x 2x can be simplified to. So I'll look at these expressions down here. Cos x, sine 3x plus cos 3x. All right, so there's a lot going on there. Now, I've got 2 coses, 2 sines. Where else have I seen that before? Well, we might remember cos A plus B is cos A, cos B, minus sine A, sine B. So this kind of looks similar to what we've got over here, except we have a minus sign here. But if this were true, we'd have something like 2x here plus an x here, and that'd be cos 3x. Well, I don't see cos 3x anywhere. But I also have to wonder, well, how can I get rid of that minus sign? And we think, and we think, and we think, and we think. Well, we might remember another property that we talked about. Minus sine x is the same as sine minus x. Okay? Or you might remember this formula. We didn't explicitly go over this one in class, if I'm remembering correctly. You could also do this. Both of them are based on the idea that sine can absorb a minus sign at the cost of a minus in its angle. Okay, so either way, you know, you remember the formula for the sum of the angles, and then you say, well, this minus sign can turn into a plus sign. Just pull in the minus b here, and that changes this to a minus b. And cos doesn't care about minus signs, so that's fine. Or you might remember this formula as well. In which case, this matches up a lot with what we've got going on here. So we could say something like cos 2x minus x is cos 2x cos x plus sine 2x sine x. Cos 2x minus x is just cos x, and that's A. Well, there we go. All right, 4. Find the solutions of the equation 3 to the x squared minus 2x is 27. Well, I know 27 is 3 to the 3. If we log base 3 both sides, we'll get x squared minus 2x is going to be 3. And so I just need to solve this. Can I think of two numbers that multiply to negative 3 and add to negative 2? Absolutely I can. Negative 3 and 1. So my roots here are going to be x equals 3 and x equals negative 1. Now these are nice integers. I could double check. 3 squared minus 2 times 3 is 9 minus 6. And that's 3 to the 3. And similarly with minus 1. So our answer is C. All right, so that's our first 4 questions done. Up next will be 5 through 8 and so on. So feel free to jump around and look at the questions that you're interested in. And I'll see you for more of the 2016 midterm later.